video, I'm going to go over the problems that are in the Unit 1 test review. So in this problem, it asks us to graph this function and then figure out what the maximum is on this interval, okay? So what you're going to do is you're going to go ahead and type this function into Desmos, and then you'll get a graph like what I've shown here. And then what you want to do is you want to look at the piece of the graph that's going from x equals -6 to x equals 3, okay? And so you can see this is the piece of the graph on that interval. And if we look at this, the maximum value is going to be the highest y value we see on this piece of the graph, right? So basically the highest point. So you can see that's going to be right here, and that's at 3, 2. Okay, so the maximum value of this function is going to be at 3, 2 on this specific interval. Okay, and that's where we have y equals 2. So now in this problem, it wants us to find the inverse of the function f of x equals 1/5 x cubed. So remember, always when we're finding the inverse, we switch f of x to y. So we have y equals 1/5 x cubed, right? And then we're going to switch x and y. So we have x equals 1/5 y cubed. So now we need to work on getting y by itself, right? We need to isolate y. So you can see here we have this cube, right? So we're going to do the opposite, and we're going to take the cube root of both sides, because we can't really do anything until we get rid of that power. So when you get rid of that power, we have the cube root of x equals 1/5 y, okay? So now what we need to figure out here is how to get rid of that 1/5, right? So how do we do the opposite of multiplying by 1/5? Well, remember the opposite of 1/5 is 5, okay? Because that's a reciprocal of 1/5. So I'm going to multiply both sides of this equation by 5. So I get 5 times the cube root of x equals y. Okay, so now that y is isolated, that is actually my inverse. So I have 5 times the cube root of x equals the inverse. Okay, so that's my inverse function. So now let's try this problem. It wants us to find the inverse of f of x equals 5 cube root of x plus 2. So remember, same steps. We're going to do f of x is y. So we have 5 cube root of x plus 2. And now we're going to switch x and y. So we have x equals 5 times the cube root of y plus 2. So now we need to work on isolating the cube root. You notice the cube root is not isolated because it has that 5 in front of it. So I'm going to do the opposite. I'm going to go ahead and divide both sides by 5. So that's going to give us x over 5 equals the cube root of y plus 2. Okay, so now to undo that cube root, I'm going to go ahead and cube both sides. So when I cube both sides, remember I'm cubing everything. Okay, so on the left side, that third power will go to both of these terms. So I have x cubed over 5 cubed, which is 125, and that equals y plus 2. Notice here y is still not isolated, so I'm going to go ahead and subtract 2 from both sides. And when I subtract 2 from both sides, I get x cubed over 125 minus 2 equals y. Right, and that is now my inverse function because I have actually isolated y. Okay, so x cubed over 125 minus 2 is my inverse. Okay, so now let's try this example. So it says f of x equals x cubed is transformed to g of x equals x plus 4 cubed minus 5. So remember, we want to use that idea of transformations, right? So we're looking for values of a, b, h, or k. So notice here that the new values that I have are this 4 and this minus 5. Okay, so that 4 is giving me like an x plus h, right? So remember, when I have an x plus h, in this case, which is x plus 4, that means it's going to shift to the left 4 units, okay? Because that's one transformation I have. Now I have that minus 5, okay? That minus 5 equals a value of k, so this is going to go down 5 units. So those are my two transformations. Remember, you can always graph in Desmos to verify. So now here it says the parent function f of x equals the cube root of x is transformed to g of x equals 4 cube root of x minus 3. So notice here I have two transformations, right? I have this and then I have this minus 3. So the 4 in front, that means a equals 4. So here I have the absolute value of 4 equals 4, which is greater than 1. So this is going to be a vertical stretch. Okay. And then I have an x minus 3. That's an x minus h. So x minus 3 is telling me that the graph is going to shift to the right 3 units. All right, so in this problem now we have a cube root equation. It wants us to solve for x. So what I'm going to do is I'm going to go ahead and cube both sides. So that's going to give me 4x minus 3 equals 5 cubed, which is 125. So now I need to work on isolating x. So I'm going to add 3 to both sides. When I add 3 to both sides, I get 4x equals 128. Now to solve for x, I'm going to divide both sides by 4. And then I get x equals 128 divided by 4, so that's going to give us 4 goes into 12 3 times, and then 4 goes into 8 2 times, so x equals 32. Now let's work on solving this equation for x. So once again, we have a cube root equation where the cube root's already isolated. So I'm going to go ahead and cube both sides. So I have 8x minus 3 equals negative 3 cubed, which is negative 27. Okay. Now I'm going to go ahead and add 3 to both sides. So when I add 3 to both sides, I have 8x equals negative 27 plus 3, which is negative 24. Now I need to divide both sides by 8. And when I divide both sides by 8, I get x equals negative 3. And that is my answer. Okay, so here it asks us to identify the center of symmetry of the cubic function f of x equals 2x cubed plus 5. So remember, the center of symmetry is kind of like that point, which we can use as like a pivot. And if we turn our graph around that point, it's going to look the same. You can also think of it as the place, like, see, this graph is like opening down and then it switches to like opening up. It's the point where that happens. And you can see that's going to happen right here at the y-intercept, which is at 0, 5. Now here it wants us to find the inverse. So remember, whenever we're finding the inverse, we switch f of x with y. So we have y equals the cube root of x minus 2 plus 7. And so now we're going to switch x and y. So we have x equals the cube root of y minus 2 plus 7. Now what we need to do is we need to work on isolating the cube root by subtracting 7 from both sides. So we have x minus 7 equals the cube root of y minus 2. Okay, so now we're going to go ahead and undo the cube root by cubing both sides. So that's going to give us x minus 7 cubed equals y minus 2. Now we need to get y by itself by going ahead and adding 2 to both sides. So we actually get x minus 7 cubed plus 2 equals y. Okay, so the inverse is now going to be x minus 7 cubed plus 2. Okay, and that's the inverse function. All right, here it wants us to find the inverse of a cubic function. So I'm going to go ahead and start off by replacing f of x with y. So we have y equals x plus 2 cubed minus 5. Now I'm going to switch x and y. So I have x equals y plus 2 cubed minus 5. And now I'm going to go ahead and work on isolating y. So I start off by adding 5 to both sides so I can get that cube term by itself. So I have x plus 5 equals y plus 2 cubed. Now I need to get rid of that cube by going ahead and taking the cube root of both sides. So when I take the cube root of both sides, I have the cube root of x plus 5 equals y plus 2. Now to get y by itself, I'm going to go ahead and subtract 2 from both sides. And when I subtract 2 from both sides, I get the cube root of x plus 5 minus 2 equals y. So my final inverse function is going to be f inverse of x is cube root of x plus 5 minus 2. So now let's work on figuring out what are the intercepts of this cubic function, okay? So you can do this by using the equation, or you can do this by graphing in Desmos. I would recommend graphing in Desmos, and what you're going to do is you're going to look for the x and y intercepts, right? You're going to look for the places where the graph crosses the y-axis and where the graph crosses the x-axis. There's also a way to do this algebraically, because remember at the x-intercept, okay, y is going to equal 0, and then at the y-intercept, x is going to equal 0. So you would have 0, comma, y. Okay, and so you can actually solve this algebraically because remember f of x is y, so we have y equals x cubed minus 27. So to find the x-intercept, I would plug in 0 for y, right? So that would give me 0 equals x cubed minus 27. And if I solve for x, I go ahead and add 27 to both sides. So that gives me 27 equals x cubed. If I take the cube root of both sides, that gives me 3 equals x. So my x-intercept is going to be at 3, 0. And you can see that when you look at the graph in Desmos, you'll see that it actually crosses at 3, 0. Also, for the y-intercept, you can go ahead and plug in 0 for x. So you'll get y equals 0 cubed minus 27. So that just means y equals negative 27. So that means your y-intercept is going to be 0, negative 27. And if you scroll in Desmos, you'll see that it crosses down here at negative 27. Okay, so this will be at 3 and this will be negative 27. But I just wanted to show you also how you can do this algebraically. Okay, so in this problem, it wants us to solve for x. So remember, what we need to do is get that cube root by itself, right? You can see here's the cube root. It's not by itself, so I'm going to work on moving all this stuff I have around it. So I'm going to start off with the add or subtract. So I'm going to go ahead and subtract 6 from both sides. So I have 5 times the cube root of x minus 2 equals 21 minus 6, which is 15. Now, in order to get the cube root by itself, I need to divide both sides by 5. And so that's going to give me the cube root of x minus 2 equals 15 divided by 5, which is 3. Now, to undo the cube root, I'm going to go ahead and cube both sides. So when I cube both sides, I get x minus 2 equals 3 cubed, which is 27. And now to get x by itself, I'm going to go ahead and add 2 to both sides. So when I add 2 to both sides, I get x equals 29. And that is the answer.